Right now, at this exact moment, somewhere beyond Mars' orbit, an object is executing maneuvers that should not be possible for a natural comet. October 29, 2025, 1400 hours Universal Time. An interstellar visitor, designated 3I, Atlas, reached perihelion, its closest approach to our Sun, at precisely 130 million miles. The date matters, the timing matters, because for the past 96 days, this object has been exhibiting behaviour that violates every model we have for cometary physics. And here is what nobody is telling you. The International Asteroid Warning Network initiated an emergency observation campaign on October 21st. Not a routine survey, an emergency campaign, the kind reserved for objects that might threaten Earth. Except 3I, Atlas, will never come closer than 170 million miles to our planet. So why the emergency protocols? Why the silence from JPL's Near-Earth Object Office? Why did ESA's Mars orbiters redirect their primary instruments away from the red planet for a 7-day observational window that ended 5 days ago? The data exists, the measurements are verified, and the numbers tell a story that makes the hair on the back of your neck stand up. Let me be clear about what we are dealing with here. 3. I-Atlas was discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System in Rio Hurtado, Chile. The Atlas Survey Telescope, funded by NASA, identified an object moving at 137,000 miles per hour with a hyperbolic trajectory. That term is not metaphorical. A hyperbolic trajectory means the object is moving too fast to be gravitationally bound to our Sunday. It came from interstellar space. It will return to interstellar space. This is the third confirmed interstellar object we have detected. First was 1I/Oumuamua in 2017. Second was 2I/Borisov in 2019. Now 3I, Atlas. 3 confirmed visitors in 8 years. Think of interstellar objects as messages in bottles thrown into an ocean between stars. Except the ocean is mostly empty space, and the bottles are moving at speeds that make our fastest spacecraft look like they are standing still. For perspective, Oumuamua was roughly the size of a football field. 2I, Borisov was a few hundred meters across. Early brightness calculations for 3I, Atlas, suggested something massive, potentially 12 miles in diameter. That created an immediate statistical problem. Based on the density of interstellar objects, we should detect 1 million Oumuamua-sized visitors before spotting something the scale of 3I, Atlas. The probability, 0.01%. 1 in 10,000. Here is where the physics gets uncomfortable. On July 7th, astronomers confirmed 3I Atlas exhibited a coma, a cloud of gas and dust indicating cometary activity. That should have resolved the size discrepancy. Comets appear bright because their outgassing creates enormous reflective clouds, not because the nucleus is massive. Problem solved. Except the spectroscopy came back wrong. 2 independent preprints, submitted within a week of discovery, reported something unprecedented. No spectral fingerprints of molecular or atomic gas in the typical ranges. No water, no carbon monoxide, no cyanide in the expected quantities. Then, on August 6th, the James Webb Space Telescope aimed its infrared instruments at 3I, Atlas. JWST can detect molecular signatures invisible to optical telescopes. The results showed carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice, an 8-to-1 ratio of carbon dioxide ice to water ice. That ratio is among the highest ever recorded for any comet, solar, or interstellar. But here is the anomaly that made the European Very Large Telescope in Chile redirect its UVES spectrograph for extended observations. Nickel, not iron, nickel. The Hubble Space Telescope captured detailed imagery on July 21st, 2025, when 3I, Atlas, was 277 million miles from Earth. Hubble's resolution revealed a teardrop-shaped cocoon of dust, classic cometary morphology. The nucleus diameter was constrained between 1,444 feet and 3.5 miles, much smaller than initial estimates, consistent with a comet, except for one detail visible in every Hubble frame: an antitail, a jet of material extending not away from the Sun, as radiation pressure dictates, but toward it. Picture this as Morse code written in vaporized rock. A comet's tail is pushed away from the Sun by solar radiation, like a flag in the wind. Always away, no exceptions. Except 3I, Atlas, was displaying a bright feature pointing sunward throughout July and August. Nordic Optical Telescope observations from the Canary Islands documented this anti-tail across multiple wavelengths. Then in September, the anti-tail vanished. The emission profile flipped. Suddenly, the tail pointed in the expected direction, away from the Sunday. Here is the terrifying part. That reversal coincided with a deceleration phase. The mass loss rate from 3I, Atlas, scaled with solar radiation flux exactly as thermal models predict. 2 million tons of material ejected between July and October, but when you do the math, that represents only 0.00005 of the object's total mass. A surface layer averaging 4 centimeters thick, ablated from a nucleus at least 5 kilometers wide. Think of it as shedding the skin on an apple without revealing what is underneath. We cannot infer the composition of the interior from the exterior shell, and here is why that matters. The chemical signature coming off that exterior shell is wrong. The UVES spectrograph at the Very Large Telescope documented nickel emission at 6 discrete observation windows between August and September. Heliocentric distances ranging from 3.14 to 2.14 astronomical units. Nickel was detected at all times. Iron was only detected at distances less than 2.64 AU. For context, every solar system comet observed in the past 50 years shows balanced nickel to iron ratios. The interstellar comet 2I, Borisov, discovered in 2019, showed nickel and iron in proportions identical to local comets. 3I, Atlas, shows a high production rate of nickel atoms and a nickel to iron ratio orders of magnitude above the solar system median. Orders of magnitude. The paper's authors noted that at the distances where comets are observed, surface temperatures are far too low to vaporize silicate, sulfide, and metallic grains containing nickel and iron. The presence of these metal atoms in the cometary coma is, in their words, extremely puzzling. On August 24th, the Keck 2 telescope in Hawaii captured narrow band images using its cosmic web imager. Those images showed nickel emission and cyanide emission with asymmetric profiles. Extensions in both the solar and anti-solar directions. Clear evidence for an anti-tail structure. But the white light image showed no evidence of a familiar dust tail pushed away from the Sun by radiation pressure. Let that sink in. The comet is producing metal vapor without producing the dust tail that should accompany it. Now let me walk you through the timeline that has JPL's Planetary Defense Coordination Office quietly escalating observation priorities. July 1st, Atlas Chile identifies 3I, Atlas. July 2nd, Deep Random Survey in Chile, Lowell Discovery Telescope in Arizona, and Canada, France, Hawaii Observatory confirm marginal coma and a short tail measuring 3 arc seconds. July 7th, pre-discovery observations recovered from Zwicky Transient Facility archives extend the observation window back to May 21st. TESS, NASA's Transient Exoplanet Survey satellite, imaged 3I Atlas between May 7th and June 3rd. Those images showed the comet was already bright and active at 6.4 astronomical units from the Sunday. Carbon dioxide sublimates at much greater solar distances than water ice. That early activity implies volatile ices distinct from water. August 6th. JWST completes its first spectroscopic pass using the NIRSPEC instrument. August 20th. Hubble refines nucleus size estimates to between 0.4, 4 and 5.6 kilometers. September 8th. Nordic Optical Telescope documents the anti-tail-to-tail transition. October 3rd. ESA's Mars Express and ExoMars Trace Gas Orbiter execute close approach observations. 3I Atlas passed within 18.6 million miles of Mars. The HiRISE camera on NASA's Mars Reconnaissance Orbiter captured images with 30-kilometer pixel resolution. That is 3 times better than Hubble's best resolution. Those images have not been publicly released. October 21st. Solar conjunction. 3I Atlas positioned directly opposite Earth on the far side of the Sunday terrestrial. Observation impossible. October 29th. Perihelion. Closest approach to the Sun at 103 million miles. Solar illumination delivered 33 gigawatts of power to the comet's surface. For comparison, that is 1/3 the total output of 94 operating commercial nuclear reactors in the United States. November 4th. ESA's Jupiter Icy Moons Explorer JUICE will pass within 40 million miles of 3I Atlas. December 19th. Closest approach to Earth at 169 million miles. March 16th, 2026. Close approach to Jupiter at 33 million miles. Juno spacecraft will observe in ultraviolet, infrared, and radio bands. The International Asteroid Warning Network does not announce emergency observation campaigns lightly. IAWN is a global partnership coordinated through the United Nations Office for Outer Space Affairs. Its mandate is to coordinate international efforts to detect, track, and characterize potentially hazardous near-Earth objects. On October 21st, the same day as solar conjunction, IAWN issued an editorial notice through the Minor Planet Center. The notice announced a comet campaign running from November 27th, 2025 through January 27th, 2026. Stated purpose: to introduce methods for improving astrometry from comet observations. Target: 3I Atlas. The notice cited challenges in accurately measuring comets due to extended morphological features like comae and tails that pull centroid measurements off the central brightness peak. Sounds routine, except IAWN does not typically announce 2-month observation campaigns for objects that pose 0 collision risk. And they certainly do not schedule preparatory workshops on measurement techniques unless there is something specific they expect to measure, something that requires precision tracking, something that might not behave like a typical comet. Let me present 3 scenarios, 3 frameworks for interpreting the data. I am not advocating for any of these. I am showing you what the numbers permit. Scenario 1. Natural comet with unusual chemistry. 3I. Atlas originated in a planetary system with different formation conditions than our own. Perhaps a metal-rich planetary collision in its birth system created a debris field enriched in nickel-bearing compounds. The 8:1 carbon dioxide to water ratio reflects formation beyond the ice line in a system where carbon dioxide condensed more readily than in ours. The antitail represents asymmetric outgassing from active regions on the nucleus surface, creating transient thrust vectors that appeared to oppose solar radiation pressure. The tail reversal in September corresponds to the comet's rotation exposing different surface areas to sunlight. Plausible, verified in laboratory analogues, requires no new physics. Probability, if all anomalies are independent, approximately 15 to 20%. Scenario 2, early warning beacon. A probe designed to sublimate layers of exotic material as it approaches stellar radiation sources. The nickel signature is deliberate, engineered to be detectable across interstellar distances. The anti-tail represents a directed emission, a broadcast. The chemical composition is a data layer, molecular language compressed into spectroscopic lines. Think of it as an interstellar lighthouse, but instead of rotating visible light, it rotates through chemical emissions. The message is not in radio frequencies, it is written in the periodic table. Every element has a unique spectral fingerprint. If you want to communicate across environments where electromagnetic interference is high, you use the one universal language, quantum mechanics. You encode information in emission lines that any technological civilization will recognize as artificial because they violate thermal equilibrium ratios. The nickel to iron imbalance is the signal. It screams, "I am not natural. Look at me." Probability. Impossible to calculate without knowing the priors for extraterrestrial engineering. If we assume technological civilizations are rare but persistent, and they would send durable probes to investigate other stellar systems, then perhaps 1 to 5%. Scenario 3, diagnostic package. An autonomous survey probe conducting in situ measurements of stellar systems. The trajectory brings it close enough to characterize planetary environments without entering gravitationally bound orbits. The perihelion pass on October 29th placed 3I Atlas at optimal distance for high-resolution spectroscopy of the inner solar system. From that vantage point, you could measure the atmospheric composition of Earth, Venus, Mars, and potentially detect biosignatures in exospheric leakage from terrestrial atmospheres. The anti-tail is not a tail. It is an active sensor beam, perhaps a plasma diagnostic or a focused particle stream designed to sample the interplanetary medium. The trajectory alignment to within 5 degrees of Earth's orbital plane is not coincidental. It is mission architecture. The arrival time optimized for Mars flyby on October 3rd, Venus approach on November 3rd, Earth closest approach on December 19th, and Jupiter flyby on March 16th. A grand tour built into the initial velocity vector from launch. Probability, lower than scenario 2, perhaps 0.5 to 2%, but with far higher implications for human civilization if true. Here is what separates speculation from hypothesis: the improbability stack. Each anomaly I have described carries its own statistical weight. In isolation, most can be explained by rare but natural processes. But these anomalies are not isolated, they are correlated. The trajectory of 3I, Atlas, aligns to within 5 degrees of the ecliptic plane, the flat disk where planets orbit. For a randomly oriented interstellar object, the probability of that alignment is approximately 0.2%. The arrival time placed 3I Atlas at optimal distances from Mars, Venus, Earth, and Jupiter. The probability of that configuration, absent intentional targeting, is approximately 0.005%. The arrival direction aligns to within 9 degrees of the famous WOW signal detected on August 15, 1977, by Ohio State University's Big Ear radio telescope. That signal remains the strongest candidate for an extraterrestrial radio transmission in SETI history. Matching that direction from interstellar space, probability approximately 0.6%, the nickel to iron ratio exceeds all solar system comets by orders of magnitude, estimating conservatively the probability of such an extreme composition arising naturally, perhaps 0.1%. The anti-tail structure maintained for 6 weeks before reversing. Natural jets can create transient anti-tail appearances, but sustained anti-tail morphology is rare. Probability, perhaps 1%. Now compound those probabilities: 0.2% times 0.0, 0.5% times 0.6% times 0.1% times 1%. You get a number so small it hurts to write down. Approximately 6 times 10 to the negative 12. 6 trillionths of 1%. At that point, you have to start asking whether your assumptions about independence are correct. Because if these anomalies are not independent, if they are linked by a common cause, then you need a framework that explains all of them simultaneously. Natural formation in an exotic stellar environment can explain the chemistry. It cannot explain the trajectory, alignment, and timing. Random gravitational scattering can explain interstellar velocity. It cannot explain the ecliptic alignment and planetary flyby sequence. Asymmetric outgassing can explain temporary jets. It cannot easily explain a sustained anti-tail that reverses polarity on schedule. We are now entering the observation window that matters. The countdown. November 4th, JUICE spacecraft executes its flyby. JUICE carries the Jovian Infrared Auroral Mapper, the submillimeter wave instrument for planetary observation, the ultraviolet spectrograph, and the particle environment package. These instruments can detect ionized gas, dust, grain composition, magnetic field perturbations, and plasma waves. If 3I Atlas is producing directed emissions, JUICE will see them. Data downlink is scheduled for February 2026 because JUICE is currently using its high-gain antenna as a solar heat shield and transmitting via low-bandwidth backup systems. November 27, IAWN observation campaign begins. Ground-based telescopes worldwide coordinate astrometric measurements. If the comet's trajectory deviates from purely gravitational motion, differential astrometry will detect it. Comets experience non-gravitational forces from asymmetric outgassing. Those forces are typically small, on the order of 10 to the negative 8 times the Sun's gravitational pull. Detectable, but barely. If 3I Atlas executes a propulsive maneuver, even a small one, the trajectory deviation will be obvious. December 1st, 3I Atlas re-emerges in the pre-dawn sky, visible from the southern hemisphere in the constellation Virgo. Brightness predicted at magnitude 12 to 13. Too faint for naked eye visibility, but accessible to amateur telescopes. The critical observation is not brightness, it is whether the nucleus remains intact. Natural comets can fragment under thermal stress near perihelion. If 3I Atlas releases subcomponents, mini-probes in the language of astronautics, they will separate slowly at first, but solar tidal forces will amplify the separation over weeks. By December, distinct objects would be resolvable. December 19th, closest approach to Earth, 169 million miles. For context, Mars at opposition comes within 35 million miles. This is not close by any standard except astronomical scales, but it is close enough for high-resolution radar imaging. NASA's Goldstone Deep Space Communications Complex in California and the Arecibo Observatory in Puerto Rico, Arecibo is decommissioned, so Goldstone and the Green Bank Telescope can perform bistatic radar observations. Radar can measure rotation rates, surface roughness, and internal structure. A natural comet nucleus has irregular rotation and heterogeneous composition. An artificial object would show regular geometry and possible spin stabilization. March 16th, 2026, Jupiter flyby. Juno's microwave radiometer, ultraviolet spectrograph, and Jovian infrared auroral mapper will observe 3I Atlas at 33 million miles. That is 1/4 the Earth-Sun distance. For an object moving at 68 kilometers per second, that is a very deliberate approach. Jupiter's gravity well makes it an ideal target for the Oberth effect, a maneuver where you burn propellant at periaps to maximize delta V gain. If you wanted to decelerate from interstellar velocity and enter a bound orbit in the solar system, Jupiter is where you would do it. Let me be explicit about what we should not see if this is a natural comet. We should not see trajectory corrections. We should not see the nucleus split into multiple discrete objects of similar size. We should not see brightness variations inconsistent with rotational modulation and heliocentric distance. We should not see directed emissions in non-cometary wavelengths, particularly in radio or microwave bands. We should not see changes in the nickel to iron ratio as a function of time. We should not see evidence of internal structure in radar returns. And we should not see any indication of attitude control, meaning the object maintaining orientation relative to the sun or planets, rather than tumbling chaotically. If we observe any of those, the natural comet hypothesis collapses, not weakens, collapses, because natural processes do not produce directed thrust. They do not produce geometric regularity, and they do not produce coherent signals. Here is what I want you to understand. This is not about belief. This is not about whether you think aliens exist or whether faster than light travel is possible or whether someone is beaming messages from Chi Sagittari. This is about following the data wherever it leads, even if it leads somewhere uncomfortable. The Copernican principle tells us Earth is not special. Our sun is one of 400 billion stars in the Milky Way. The Milky Way is one of 2 trillion galaxies in the observable universe. The chemical elements that make up our bodies were forged in stellar cores and distributed by supernovae. The molecules that became life on Earth are common in interstellar space. We have detected water, amino acids, and complex organic molecules in comets, asteroids, and the atmospheres of exoplanets. The ingredients for life are everywhere. The universe is 18 billion years old. 13.8 billion years old. The sun is 4.6 billion years old. Earth is 4.5 billion years old. Life arose on Earth by 3.5 billion years ago, less than 1 billion years after the planet formed. That means there has been time for countless civilizations to arise, develop technology, and disperse probes throughout the galaxy. If even 0.1% of stellar systems develop technological life, and even 0.1% of those civilizations build self-replicating probes, the galaxy would be saturated with artifacts within 10 million years. That is the Fermi paradox. Where is everybody? Maybe they are here. Maybe we have been looking for radio signals when we should have been looking at the rocks flying through our solar system. Maybe the message is not in electromagnetic radiation. Maybe it is written in nickel, vapor, and carbon dioxide ice ratios that make no thermodynamic sense. Maybe the anti-tail is not a tail. Maybe the alignment is not a coincidence. Maybe the timing is not random. Or maybe 3i, Atlas is just a comet. An unusual comet from a stellar system with different chemistry, visiting our sun on a trajectory sculpted by random gravitational scattering across light years of interstellar void. A cosmic accident that happens to look designed because we are pattern-seeking creatures, hardwired to see intention in noise. Both explanations exist within the bounds of known physics. One requires only chemistry and dynamics. The other requires technology, intention, and the existence of non-human intelligence. The data does not yet distinguish between them, but the data will. Over the next 4 months, every major observatory on Earth and in space will watch 3i, Atlas. The telescopes are already booked. The observation protocols are already written. The data pipelines are already tested. We will measure the trajectory to centimeter precision. We will resolve the nucleus to kilometer resolution. We will decompose the spectroscopy to individual emission lines. We will track every photon, every radar echo, every astrometric measurement, and when the data comes in, we will know. Not believe, not speculate, know. If you want to stay on the timeline as this unfolds, now is the time to subscribe, because the next 4 months will rewrite either cometary science or human history, and I will walk you through every data release, every trajectory update, every spectroscopic anomaly as it happens. This is not a story that ends with a conclusion. This is a story that ends with an observation. Here is the question I want you to answer in the comments. When you look at the improbability stack, when you see the trajectory alignment, the timing, the chemistry, the anti-tail, the ecliptic orientation, the wow signal direction, when you compound those probabilities and get 6 trillionths of 1%, are you looking at the universe's capacity for generating rare coincidences? Or are you looking at contact? Is this pattern seeking, or is this the pattern? Because the answer changes everything. Not just what we think about 3i, Atlas, what we think about our place in the universe. Whether we are alone in the dark or whether the dark has been watching us all along, sending slow boats across interstellar distances, wrapping messages in ice and metal vapor, timing arrivals to the day, aligning trajectories to the degree, broadcasting in the one language that cannot be mistaken for noise, anomalous chemistry in the vacuum of space. The countdown is running. November 4th, JUICE flyby. November 27th, IAWN campaign begins. December 1st, visual recovery. December 19th, Earth approach. March 16th, Jupiter flyby. 4 months, 120 days. The most intensive observation campaign ever directed at a single object in the solar system. And when it is done, we will have either the most detailed characterization of an interstellar comet ever achieved, or we will have something else. Something that forces us to update the priors we use to calculate the probability of technological civilizations. Something that turns the Fermi paradox from a question into an answer. Are we alone? Right now, the universe is sending us data to answer that question, not in radio signals from distant stars. In the trajectory of a visitor moving at 137,000 miles per hour, carrying nickel vapor in ratios that should not exist, oriented on a path that threads through the orbits of 4 planets, arriving on a timeline that puts it behind the sun during perihelion, invisible to Earth-based telescopes at the exact moment when any propulsive maneuver would be most efficient. Coincidence? Maybe. Probably. The natural explanation is always the more parsimonious. Until it is not. Until the weight of compounded improbabilities forces you to consider frameworks you would rather ignore. Until the data leaves no room for comfortable assumptions. 3i. Atlas is out there right now. Beyond Mars' orbit, cooling as it recedes from perihelion, shedding mass at 2 million tons per month, broadcasting nickel lines into the void, carrying whatever secrets are locked beneath that 4-centimeter ablation layer. In 4 months, we will know more. In 4 months, we might know everything. Or we might just know that the universe is stranger than we imagined, and that strangeness has a trajectory, and that trajectory is aimed at us. Watch the sky, watch the data, and remember that the most important discoveries in human history were never announced with certainty. They were announced with a question mark, a probability distribution, and a willingness to follow the evidence, even when the evidence leads somewhere we have never been before, somewhere we were told we would never go, somewhere between the stars, where the rocks are moving too fast, where the chemistry makes no sense, where the alignment is too perfect, where the timing is too precise, where the pattern is too complex to be noise, but too subtle to be proof. Yet the observation window is open, the instruments are ready, and 3i, Atlas, is not waiting for permission. It is already here. It has always been here. We just did not have the tools to see it until July 1st, 2025, when a telescope in Chile caught a glint of reflected sunlight from something that should not be there, moving in a way that should not be possible, carrying a message we are only beginning to learn how to read. That is where we are. That is what the numbers say. And the numbers do not lie. They just ask questions we were not ready to answer. Questions like, what happens when the universe decides to introduce itself? What happens when the message is not in our language, not in our physics, not in our expectations, but in the periodic table, in trajectory mechanics, in statistical anomalies compounded until coincidence breaks down and intention emerges? What happens when we stop looking for signals and start seeing them everywhere, written in ice and metal, in arrival times and alignment angles, in the gaps between what we predicted and what we observed? What happens when 3I Atlas reaches Jupiter and does not do what comets do? The answer is coming. November, December, March. Count the days, watch the trajectory, and understand that for the first time in recorded history, we are not searching for alien intelligence. We are tracking it across 170 million miles of vacuum through 4 planetary flybys into a data set that will either confirm our loneliness or shatter it. There is no middle ground anymore. The probabilities are too small, the alignments are too precise, the chemistry is too wrong. And the countdown has already started. This is not speculation. This is observation. This is not belief. This is measurement. This is not hope or fear. This is data, and the data is screaming.